Okay, welcome back. We're on page 448 talking about this decision tree and how you can use, expected monetary value, EMV, and unfortunately it's almost like earned value management, EVM, so I probably will say it wrong. You'll just have to translate. Anyway, the idea is a decision tree could basically tell me, I only have an 80% chance of losing my shirt and 20% chance of making $60,000 and all the rest of the stuff. Anyway, all right. So it tells me the financial gain of each step. Basically, each decision, I know how much this decision costs me. Okay. That's what it's all about. And in theory, you could use this to select the best choice of alternatives, all based upon money. This decision means this amount of money. This machine means that amount of money. Okay, cool. So that's one way. The other way is just this simulation where I go in and tell the computer it's gambling essentially, and they call it the Monte Carlo analysis. And Monte Carlo analysis is pretty doggone cool. Basically, what you do is, I don't really know what this thing is going to, I don't know, whatever it is, cost, schedule, time, something. And so you give it the most likely cost, and then the pessimistic cost and the optimistic cost. So you have your bracket, you have a triplet. What you expect, what could probably be the lowest and probably the highest. And so you plug this into the computer, and so let's say you have 5 variables that you have to deal with. I have a cost variable and a time schedule and whatever. And so you do that for each one of these things. And so you actually tell the computer to just pick a random number inside that range for all these variables and produce a result. They'll do it over and over and over and over as many times as you like until you can kind of settle on what you think the outcome number is going to be. And so you end up with a confidence of, okay, this is what's likely going to occur. It's actually kind of cool. So with Monte Carlo analysis, one of the things you could say is, let's say I'm trying to figure out what my end date is for a particular project. I could say, run the analysis and tell me that what date is probably going to have like 50% chance of being met. I'd like to know that. What date would probably be the 75% chance of being met? So 50% chance says, well, it's going to be done on April 2nd. And the 75% chance is, May 1st, right? I mean, you could go to absurdity and say 100% chance, and that'd probably be like June or something, but that's not realistic. So you're kind of trying to bracket in your choices. So you pick a level of uncertainty, like, 75% chance of this working is probably what I want to go for. So what's the end date? What's the 75% probability end date? So you run this analysis and it'll pop out a date saying April 3rd. Cool. All right. So let's go through it. So step 1 is collect the likely, the optimistic, and pessimistic estimates for each one of the variables, whatever those variables might be. Do what's called a probability distribution, and I'm going to go ahead and switch over to this little chart. So here's like the completion date. This is cumulative probability, but looking at it slightly different. So if I had picked 50% as my thing, it looks like that would be the date where it would be 50% chance of it occurring on that date, right? My sample. Okay. So I know this is a lot of math, so just bear with. By the way, no one does this by hand. Microsoft Excel does an excellent job of doing this stuff. I pick 95% confidence value and I run through some numbers and tell me what the probabilities are. And so clearly, if my probability was 100%, right? Well, then it'd be a date that's way far out there. In reality, I probably want somewhere around 75%. And so in this particular case, I'd pick the 22nd of February. So 22nd of February would probably be about, I'm guessing, about right there. 75% chance of me hitting that date right there. Okay, so doing a distribution curve, okay. Select a random value based upon the probability of distribution, right? So I picked a random value. and then run the deterministic algorithm, and then just do it over again. Go back to step 3, and select a random number and just do it over and over and over. In this case, did 250 iterations to produce these numbers, and so that's pretty decent. Okay. So again, I'm not trying to bore you with the math because, quite frankly, Microsoft does this for you. You basically, you can tell it, put some random numbers in there and tell me what it's going to be. And it'll produce this stuff for you, so you don't have to worry about doing the math. But you understand the concept. The concept is I have a bracketed value for this factor and that factor and that factor and that factor. All right, let's do something a little simpler. All right, let's say, for example, that I don't know what my interest rate on my loan is going to be. But I have like a high and a low, and probably what it'll be. I don't really know how many months I'm going to have this loan. It could be maybe a low of 48, maybe a high of 72, and 60 is kind of what I'm thinking. I don't really know how much this car is going to cost. It could be $30,000, it could be $40,000, but I think it's about $35,000. So if I don't know the interest rate, don't know the period, and don't know the cost, what's the likely car payment am I going to have? Right? Be like, well, that's what you would do. You would run each one of those factors and over, just randomly, until you come up with a distribution looking something similar to this, where you could say, okay, most likely my car payment is going to be $742.18. Okay, that's what we're talking about. Cool. So, on page 451, they talk about this in a little bit more detail. It's called sensitivity analysis. Sensitivity analysis is when you pick one particular element. Not Monte Carlo is using all of the elements, right? All the factors. Sensitivity analysis, I pick one and say, how much of an effect is this going to have on my car payment? If I was just to change the interest rate from 2.5% to 3.5%, so you just tweak that number up and go, oh, so okay. Well, what happens if I change the period of the loan? Instead of 60 months, it's 48 months or whatever, and you pull that down and go, oh. So sensitivity analysis is about trying to find which one of these factors has the most influence. A 10% change in interest rate, or 10% change in the period, or 10% change in the cost of the loan, the amount of the loan. Which one's going to have the most impact? Would you happen to guess? Okay. So, Microsoft Excel actually can do this for you. This is an example of a profit analysis where, basically this is actually trying to do the break-even point, where I'm assuming I'm going to sell this many units, and I'm assuming I'm going to make this much, and here's my expenses per month, and so I'm trying to find the point where the two paths cross. And so you just kind of do this kind of analysis and go, well, let's change the sales price to 13, and that little blue dot will go, doing. Oh, what happens if it costs me $8.50, and doing, it'll pop on over. So you're doing sensitivity analysis, manipulating just one particular point and seeing where things are happening. Okay, cool. By the way, again, Microsoft does this for you. You don't have to do any math to make this thing work. Thank goodness. Okay. So we made it through the quantitative part. All right. The next one is planning risk response on page 452. Now, there's several ways you can deal with risks. And so let's just talk about some broad classifications of risk. The first one, which is probably the most appropriate one, believe it or not, is called avoidance. Now, that doesn't mean I'm not going to talk about it. That's ignorant. We're not talking about ignorance is bliss. We're talking about avoidance. Avoidance basically means don't do that anymore, whatever it is that's causing the risk. And so back to an IT scenario. Let's say, for example, that I have a mom and pop store, and I have to take cash and credit card receipts, and I put them in a safe in the storefront, and I'm thinking, somebody could break in and cut into my safe or run off with my safe. So one of the things you could do is just don't do that. Take the money to the bank every single day, not even have a safe. So that's risk avoidance. Basically, you make that risk go away by doing something different. Okay, so risk avoidance. Acceptance. Risk acceptance basically means, hell, let's just let it happen. In other words, it's going to cost me way too much money to make that risk go away, and the likelihood is low and the impact is low, so what the heck? I'll document it. I'm not going to say, what? I don't know anything about that. No, you're going to document it, but you're also going to say, I'm not planning on doing it. The cost of managing the risk is greater than the risk itself. Okay. Transference. Transference is a fantastic scenario. Let's say, for example, that I have a website for a business, and I do credit cards, and one of the risks is somebody's going to break into my web server sitting over in the corner of my storefront. Okay. They're going to hack into it. They're going to do something, and I'm not really a computer expert. I just do boot repair or Beanie Babies or sell kumquats or whatever it is I do for a living, and website really ain't my thing. So there's a high risk that something's going to go wrong. So transference would basically mean I don't host my web anymore. I have a third party do it. So I go to a web service provider and say, I want you to host my web. I transfer the responsibility. Now, clearly the risk has not changed. There's still a risk of somebody breaking into the website. The difference is it ain't your job to do it anymore. So risk basically means passing the buck. So sure, the same amount of risk occurs, but now it's my hosting provider's job to provide the security, not me. Cool. All right, so I kind of like those. And then the last one is mitigation. There's two forms of mitigation. One would be to attempt to lessen the probability, makes sense, or to lessen the impact if it does occur. And of course, those are, highly, you can those are very, very issue specific. Right. So mitigation is probably the last. Probably I would try to go for, avoidance first, like make the problem go away. Woohoo! Transfer second, mitigation third, and the fourth one would probably be the acceptance, where I say, too bad. I'll just let that happen. Okay, so some strategies. Strategies for positive risks. Okay, so positive risks, one of the things they talk about is this table talking about, this is 11.7 on page 453. They talk about technical risks, cost, risk, and scheduling. So, emphasize team support and avoid standalone projects. Increase project manager authority. Use, cost management stuff and all the rest of these kinds of things. So, those are some, strategies you can use for reducing technical risk, cost risk, scheduling risk. From a positive perspective, they have this thing called exploitation. Exploitation basically means make sure the risk happens. Remember, we're talking positive. So do whatever you can to make sure this thing does occur. Okay. Sharing, which means spread the project around. Make sure that other organizations can also benefit in this thing. Enhancement, basically change the size of the opportunity. Once you've got your foot in the door, so to speak, see if you can also get, this, and this. Acceptance. Basically, acceptance is the same in positive risk. Acceptance is the same as negative, which means don't do anything at all. Just let it happen, which is an available strategy. Controlling risks on page 454. So basically, we're talking about the tools that are available to monitor these things, because I mentioned that risk will change over time. So risk measurement, right? Some sort of risk audits would be a good way of doing it. Variance and trend analysis, for example, if an EVM value goes above or below something, that's probably one of those triggers when we talked about that risk registry, what the triggers were. Hey, we're coming up on the 15-minute mark, so we will finish this off in just a few more minutes.